Hi, this is a small video presentation on the practical project of this EN 8912 Applied Thermodynamics course. The title of the project is Cogeneration Power Plants Performance and Enhancement. So, this involves two varieties of two stages. This project should be completed in two stages. In the first stage, you will estimate the performance of the existing power plant, and in the second stage you will enhance this power plant by incorporating some other components in the analysis. So you will make it in the second. After completing the second stage, the plant will become a cogeneration power plant. So after completing these two stages, the plant will become a cogeneration power plant, and its performance should be higher than the existing power plant. That is what is the task in this practical project. Because of the problems that occurred from COVID onwards, we are unable to visit power plants as a group from Polytechnic. So uh, we will discuss what to do in this project analysis in the next couple of minutes. Now, starting with the learning outcomes, all the four learning outcomes will be assessed in this project task. And the due date for submission is 23rd May. You have more than 1 month time from now, before midnight. And come to general description of the power plant. There are actually four major power plants with a total installed capacity over 2000 megawatts in Bahrain. And what you have to do is, see, in one of the power plants, there is a mixed cycle with five gas turbines and one steam turbine. Five gas turbines and one steam turbine. And you will be updating this power plant in this analysis, in this project, as I told you before, in two stages. Okay. Now, what your role actually is, assume you are given a chance to work for that company, for that power plant, and your line manager has given the task of estimating the performance of the power plant and to enhance the power plant by using both stages. Now, as a design engineer, what you have to do is to provide a new design for the entire system in order to increase the plant efficiency. The two stages involved in this project completion are: in stage 1, you will first analyze and then enhance the existing power plant by just adding or incorporating feed water pumps and feed water heaters. This is the first step. So after first step, what you will do is you will analyze and enhance the existing power plant by adding feed water pumps and feed water heaters. In the second stage, you will design a cogeneration power plant by upgrading the system that was already analyzed in stage 1 using any Brayton cycle. So, you have to understand what is the thermodynamic cycle involved in the power plant, and in the second stage you will analyze the Brayton cycle and how you will add this Brayton cycle to the existing power plant so that the performance will be enhanced to make it a cogeneration power plant. This is the task, the main task. Now, from this paragraph, you will understand what is actually the cogeneration power plant and what is its purpose and advantages, etc. And what is the performance factor of cogeneration power plant, which is utilization factor. You will do a small research on this and you will proceed further. So, before going for the technical information, let me take the first step that is involved here, which is the data to be taken for the analysis. The first step is to obtain the technical information mentioned above in this paragraph. We will come back this paragraph once again, which is required for this analysis. You will conduct an in-depth research on any power plant in the Kingdom of Bahrain. This can be done in two stages, in two steps, either of these two steps. The first step is If you have any direct contact with any power plant in one of the renowned power plants in Kingdom of Bahrain, you can visit in your own, in your free time, or with your permission. It's up to you. If you have a chance to visit, you can visit the company, take the necessary data required in this paragraph. You see here, you have to read this paragraph completely, thoroughly, okay, and you will get the technical information that is required for completion of this project from the visit, from the power plant visit. If you don't have a chance to visit any company, you will do an online in-depth thorough research, extensive research on this power plant, on any power plant, either online, you can Google it, you can do whatever you want. You can get the data that is required for the power plant. So you can get the data either from visiting the company, the power plant, or by doing online research. For that data which is required here, you can go ahead with the analysis. Suppose if you are unable to visit the company, a power plant, or if you are unable to get online research, from online research, you can use the second step. Second step is the table that is provided to you only if you fail to get the data from power plant visit or online research. Look at here. Please use the following table to select the data for the technical parameters only if you are unable to obtain the necessary information from step 1 above. So, you will take the data provided here from this table only if you can't get the information from step 1 above. Step 1 has to either of two sources. One is power plant visit, or power plant visit in your own, or online research. So, in this table, the technical parameters provided here are, now let me go back to the technical information paragraph. M1 tons per hour of superheated steam enters the high pressure turbine at some temperature and pressure, and it is discharged isentropically until the pressure reaches some other pressure. After exiting the high pressure turbine, some other quantity of steam is extracted to the open feed water heater, and the remaining steam flows to the low pressure turbine, where it expands to another low pressure. At the condenser side, the steam is totally condensed. The temperature at the condenser's outflow is the same as the saturation temperature at the same pressure. The liquid is then compressed to P2 bar after passing through the condenser and then allowed to flow through the mixing preheater, which has an efficiency provided here, where it is completely condensed. The preheated feed water will be fed into the heat exchanger through a second feed pump, where it will be heated and superheated to a temperature of T1 degree centigrade. In the winter, the overall process heating demand is assumed to be Q dot megawatt, while this power plant electricity demand is E dot megawatt. So, these two should be taken from the company visit, or from their company website, or some other sources, or you can take from this table. So, M1 dot tons per hour, minimum you have to take 10 tons per hour and maximum 15 in step of 0.5. It means either you take 10 or 10.5 or 11 or 11.5 or 12 or 12.5, etc., up to 14.5 or 15. M2 you will take from 1 to 1.5 in step of 0.1. So, 1 or 1.1 or 1.2 or 1.3 or 1.4 or 1.5. T1 degree centigrade is 450 to 550 in step of 5, like 450 or 455 or 460 or 465 and something like that. Similarly, pressure P1 varies from 20 to 30 in step of 1, P2 from 4 to 6 in step of 0.2, P3 from 0.4 to 1 in step of 0.05. Efficiency of heat exchanger will be 82% to 88% in step of 0.5, and Q dot megawatt is 1.2 to 2.2, and E dot electricity demand is 5.5 to 6.5 megawatt. So, this is the data that you have to take only if you fail to get the information from company visit or from the company website or any other source. This is about the task. What you have to do, you have to do a thorough research on the analysis. What is the efficiency, present efficiency of the power plant, and what should be the improved efficiency or enhanced efficiency of the power plant? What should be the deviation from your uh, uh, um, project report? So the report should include all these information, such as summary, which includes maximum of 200 words or one page, assumptions, which is very very important for this analysis, maximum of 150 words to one page. Similarly, introduction part, theoretical aspect and analysis, schematic of the power plant. This is pretty much required. You can draw very nice schematic of the power plant by using any graphical application such as Microsoft Visio or any other flowchart tool or something like that. And you have to show property diagrams, both pressure volume property diagram and temperature entropy property diagram. Both should be shown very clearly, maximum one page, half page for pressure volume and half page for temperature entropy. In the results and discussion part, you have to include all your project findings, including results, specific methodology, calculation part of various parameters, stepwise parameter, including the quantity of feed water, the calculations for other parameters such as efficiency of the power plant and utilization factor, overall efficiency of the plant, etc., etc. Everything should be included in the results and discussion part. And after that, what are the conclusions and what can you recommend for further improvements? And in analysis of technical difficulties, this is pretty much required for this task, because since you are asked to do some research or you are asked to visit any industry power plant, you might face some technical difficulty, or you might face some difficulty in calculating some parameters, in getting some other parameters or something like that. And those difficulties should be narrated here, should be presented here in this part of the report. So those technical difficulties should be placed here in this report for a maximum one page. And you must include the high quality references, but there is no limit for that, but it is mandatory. You must include some references, but there is no limit for that. Even appendices also, if it is required, if you feel that it is required, you can submit. Otherwise, you can include. Otherwise, there is no restriction for appendices also. Now, with regards to assessment details, it is 40% of your final grade, and late release applied. You must submit before midnight of 23rd May, and it is individual assessment. You will submit a soft copy onto Moodle page. No receipt rule. There is no must pass, and all four learning outcomes will be assessed. Same format that we already followed for the blended learning, which is A4 size, page margins, font style, etc., etc. And again, you can use this learning outcome wise evaluation criteria for each and every rubric component. This is how you will be your report will be graded. And here is the rubric for grading this report. Thank you.